Calculus 1 class. In this video, we're going to just talk about the derivative of the trigonometric functions. And what I got right now is the sine curve. So that's a sine wave. You can see the multiples of pi and pi over 2 down here at the bottom. And what I'm going to do is I'm going to press, let me just slide this manually for a second so you can see what's going to happen. As I move this, this is the tangent line of the sine curve. I'll move over just a little bit. You can see it's tangent to the red curve at that single point. And as I move forward, what we're going to see is it's going to evaluate the slope of the tangent line at these different values. So it's starting at negative 3 pi, and you can see it's a steep curve. It's slightly less steep here. It's slightly steeper, and then it kind of peaks in steepness, and then it starts becoming less steep. Right, and so the blue dots are just the slope. I'm marking the value of the slope at all these different places on the red curve. So you see a little tangent line up here. That's a horizontal tangent line, and you can see the horizontal tangent line has a slope of 0. These are those previous slopes of the tangent lines that you're seeing. So as I keep moving forward, I pick up a new tangent line. That tangent line, the little blue tangent line, has a slope here of this value. All right, 1/2. And again, I can just keep moving forward, get more tangent lines, plot their slopes, and you can see I'm peaking. That's the steepest positive slope that I'm seeing, and it becomes less steep the further I go to the right. So I'm just going to press play on this. And so as I go, again, I'm just getting more and more slopes plotted. The blue line segments, their slopes are the blue dots. And the negative slopes, the blue dots are below the x-axis, positive slopes, the dots are above the x-axis. And as that continues on, we start to see hopefully what is a very familiar curve to you. I've sped it up a little bit just to kind of get to the end. And as we see this, as it fills in, this is the graph of the cosine function. So the slopes of the tangent lines for the sine function are given by the cosine function. That is, the derivative of sine is cosine. All right, but that's just a little visual aid. It's not really the proof. We can prove it easily, but we have to use this sum formula for the sine function. So if I replace this with this formula, and recall that this is x and h, so that's going to be x. Everywhere I see alpha, it's x. Everywhere I see beta, it's h. So this is now the limit as h approaches 0. So if I apply that sum formula to sine of x plus h, I end up with this, which I'm just replacing it down here. All right, and then I'm subtracting the sine function divided by h, taking that limit. Now what I'm going to do here is I'm going to take anything that has sine of x in it, which is these two. I'm going to group those together. And then this part right here that does not have a sine of x, it's going to get its own limit. So I'm going to break this up into two limits. The limit as h goes to 0, the stuff with sine x. So there's the two sine x together, and then this over here is the one that doesn't have sine. And I'm just broken them apart with this plus sign, right, over two limits. Okay, and it's fine to do that. That's one of the limit laws. If you have a limit of two continuous functions at that have addition and or subtraction together, you can split them up into multiple limits across the addition and subtraction. So that's what I'm doing. I'm just using that plus sign right there to break this up into two limits. All right, now what I'm going to do here, because h is the one that's going to 0, x is not a part of the limit. It's h going to 0. So anything that has only x's, like this has only an x, this has only an x, this has only an x, these things can be factored out of the expression and pulled out of the limit. So I can replace or remove this sine of x and say that's the limit as h goes to 0 of just the cosine minus 1 over h. So again, there's the cosine. Sine is being multiplied by, you can think of it as like -1 right there. So when I factor out that common sign, I'm left with the cosine and the -1 over the h. Right, same way over here, I've got a cosine that I'm completely factoring out, and I'm left with this sine h over h in the limit. We're going to do these graphically for now. We will do these limits later on in the semester. There's a tool we need to be able to do them, but just notice right here, these are, the x-axis is h, because that's a function of h. And this is the cosine of h minus 1 over h. That's what we have in this first limit that we're taking. And you can see as h approaches 0, and that's the limit that we're taking, as h approaches 0 here, you can see that the y-coordinates approach 0. Okay, so that's the limit. The closer I get to 0 with h, again, that's the x variable here, the limit, the y variable, is 0. So we're getting really close, and it's approaching 0. So that's the limit of this top function. The bottom function, sine h over h, that is the limit we're seeing here in the second limit. And the sine of h over h, as h approaches 0, you can see there, we approach 1. Okay, there's a hole there, but as I get closer and closer to left and right side, the limit does exist, and the limit is 1. So this limit right here is approaching 0. This limit right here is approaching 1. So we get sine times 0 is 0. Cosine times 1 is just cosine. All right? Now follow that up. What did we just show? We showed, if you follow the path, the derivative of the sine function is, do all that math, the cosine function. So the derivative of sine is in fact cosine. All right, the derivative of cosine is just a little bit different because we get a different, the sum formula for cosine has cosines together and then sines together, but the big thing is it has a negative sign between them. So when we expand within the cosine x plus h and get cosine cosine minus sine sine, and we combine the stuff that has cosines together, factor out that cosine, we're left with this cosine h, and then again the minus 1 from over here. So we get this with cosine, and we know that that again is 0. So the cosine is going to go away. Then the thing that's left, the sine x, sine h over h, well, that's got a minus sign in front of it now. And so when we factor out the sine and we get the sine h over h, well, that goes to 1. And so we get a 0 minus sine times 1. That's negative sine instead of positive sine. So the derivative of sine is cosine, but the derivative of cosine, is very important that you remember, is negative sine. It's not positive sine. That's a really important distinction between the derivative of sine and derivative of cosine. Now for all the rest of the trig functions, we're not going to do anything similar with the x plus h. We're just going to use the fact that they can all be defined by sine and or cosine. So once we have their definition in terms of sine or cosine, then it becomes just the quotient rule after that. All right, so recall for tangent, that's sine over cosine. The quotient rule says the bottom times the derivative of the top. The derivative of sine is cosine. All right, and then minus, now do the top, sine, times the derivative of the bottom. The derivative of cosine is negative sine. And then we divide all of that by the denominator squared. So that would be cosine squared. Okay, cosine, cosine, that is cosine squared. Negative sine times another negative sine. That's actually plus sine squared. All right, and then they're all over cosine squared. Now you got to remember, you can't do this. That's a big no-no in math. So don't try to do that. But instead use the fact that cosine squared plus sine squared is always 1, and then cosine squared is on the bottom. And then cosine is the reciprocal of secant. So 1 over cosine squared is secant squared. So now there's our derivative of tangent. All right, we've seen how to do tangent, so we're going to do cotangent exactly the same way. The bottom, which is sine, times the derivative of the top. The derivative of cosine is negative sine, minus the top, cosine, times the derivative of the bottom. Derivative of sine is cosine. All right, all over the denominator squared, that'll be sine squared. All right, now this is negative sine squared minus cosine squared. And then on the bottom we have sine squared. All right, and then negative sine squared minus cosine squared, I can pull a negative 1 out, and then that becomes sine squared plus cosine squared. That is equivalent to 1. So negative 1 times positive 1 is just a negative 1 over sine squared. And negative 1 over sine squared is the same thing as the negative cosecant squared x. All right, now we're going to move on to the two reciprocal functions, meaning the reciprocal of cosine is secant. So secant is also the reciprocal of cosine. Now when I do the quotient rule here, the derivative of 1 is 0. Any constant's derivative is 0. So bottom times the derivative of top, well, the derivative of 1 is 0. So that's just going to go away. Minus the top times the derivative of the bottom. Derivative of cosine is negative sine. And then on the bottom, I'm just going to square cosine. Cosine squared x. All right, this is gone, but a negative times a negative is a positive sign on top. And then cosine squared, I'm going to write it as cosine times cosine. And you'll see why in just a second. But sine on top, I can write it as sine times 1. And now I'm going to split this into two fractions. Remember, when you multiply two fractions together, you just multiply numerators, multiply denominators. So that means I can also split this up into two different fractions. And what I have here is the tangent, and then what I have right here beside it is, again, the secant. So the derivative of secant is tangent times secant. Sometimes you'll hear me say it, and I do say it more often than tangent times secant. I'll say secant tangent. All right, then cosecant is 1 over sine, so bottom times the derivative of the top, again, is 0, minus the top times the derivative of the bottom. Derivative of sine is positive cosine. All over the bottom squared. We're going to do the same thing that we did before. We're going to say this is negative cosine over top of sine times sine. All right, and then I'll put a 1 up there with the cosine. So I have a negative cosine over sine and a positive 1 over sine. So I'm going to just pull that negative all the way out. Cosine over sine is cotangent. 1 over sine is cosecant. So there's the sixth and final trig derivative. And then the one thing that I want you guys to pay close attention to here, and you may have already observed it, is that any time that the trig function starts off with co, right, we end up with a negative in our derivative. All right, and other than just the cosine and sine, the rule for tangent no co is secant no co. The rule for cotangent is cosecant squared. All right, so not only is it negating it, I'm just saying co in front of what I would say up here for this derivative rule. Secant derivative was secant tangent, cosecant, cosecant, cotangent. Okay, so I think of it as like there's like three big rules, and then the cos, remember the negative signs, and also the cos derivatives basically mirror the derivatives of the non-cotrig functions.